So we're going to spend a little bit of time solving equations. Basically, you're looking for what x is, and you're just trying to find it. Ultimately, you can put most of these into Desmos and solve, and I will show you how to do that. But I do want you to have an idea about how you would solve this algebraically, just so that if the problem was really weird or if Desmos was hard to find the answer, that you're able to do it without having to just use Desmos. Like I said, Desmos will work on most all of these, but I want to show you the real process just in case. Now, we'll be doing equations. We'll also be doing some more problems, but the process is the same. So, if you have exponential equations, when the bases are the same, you just set the powers equal to each other and solve. Okay? So what I mean by bases being the same, if you have 2 to the x and 2 to the 5th, you see how both of those are at 2? The bases are the same. If this would have said 4 to the x and 2 to the 5th, the bases are not the same. Okay? But the bases are the same here. So you just set the powers equal, and on this one that means x is 5. On number 2, are the bases the same? Yes, because they both have a 4. So you set the powers equal. You want to get x by itself, so you would add 5 on both sides, and you get x is 8. Number 3, again, the bases are the same. You set the powers equal to each other, and then you solve for x. So on this problem, I would probably subtract x on both sides. Excuse me. And then subtract 1 on both sides. And I get a negative 3. So, pretty simple, even without Desmos, so that's really nice. And when we get through 1 through 10, I'll show you on Desmos the process. Alright, number 4. The question says, if the bases are not the same. There's lots of things you can do when the bases are not the same, but I'm going to show you one way to solve it. What happens is you change the equation to a logarithmic equation, and then you solve. Right here it says make sure to get the base by itself first. Number 7 is a problem where the base is not by itself first. You would have to do something else on number 7 before you can solve it. Okay? So what you do, it says 4 to the x equals 20. What you do is rewrite it in exponential form pretty much. Okay? So if I rewrote this in exponential form, I'm going to have log. My base is 4, so 4 goes here. Remember, it goes 4 all the way to there and back to the power, so 20 goes here, and then x. So after you rewrite it in logarithmic form, then you can just find out what log base 4 of 20 is. And a lot of times you're going to get decimals. If you want to round it to 2 places, we could just get in the habit of 2 places. Because even if you're talking about money, it's 2 places, so we'll leave it at that. So number 5, if I rewrite that in exponential form, 20 is the base, so 20 would come down here. I go all the way around, so 56 is here. And then the power is next. So in Desmos, I'm going to put 20 there, 56 there, and we get 1.34. Alright, this one's just a little bit more tad tricky just because it's got a 2x in the power. But you still want to rewrite it in exponential form first. So log base is the 5, go to the 62, and that equals 2x. So in Desmos, you would plug in the 5, plug in 62, we get that, 2.56. But that's not the answer because it says 2x equals that. So what would we do to continue solving it? Divide by 2. And so up here, if you wanted to put divide by 2 right there, you could. And you get 1.28. I'm going to put it on this side since I'm in another room right there. Now when you do number 7, this one again is just a tad bit different because it's got this plus 3. I do need to get rid of that plus 3 first before I write it in exponential logs. So I'm going to subtract 3 on both sides. And then I now have 5 to the x equals 1. You may know this answer without having to solve it. But if you don't, I know that 5 is the base. I know that 1 goes here. And I know that x goes there. This comes out to be 0. You can put it in Desmos if you want to, but you do get 0 there. Now, before I show you these last 3, I just want to show you real quick, if you wanted to not solve them and just put them in Desmos totally, what you would do, like on number 4, you would put 4 to the x, get everything equal to 0, so subtract 20, and this is kind of like what we've done before. Find the zeros, 2.16, that was our answer. Okay. If I wanted to do, let's say I wanted to do that last one because it was a little bit harder, a little bit more work there. So I would do 5 to the x plus 3. Don't forget to subtract the 4 to make it equal to 0. Find out where it crosses the x-axis. We got 0. 0 is the answer. So to get rid of the log, we're going to do exponential form. So we start with the 36 and raise it to that power. And then we set it equal to whatever it was beside the base. So we would put 36 raised to the 3 halves, or 3 divided by 2. Oops, not 5, 2. And I get 216. You can do it that way, or you can like put it in, subtract it, find the zeros. Just you might have to play with that graph a little bit to try to find it. So 216 is what we get there. So basically, if there's not a log there, you want to put it in log form. If there is a log there, you want to put it in exponential form. Okay. So I want to put this one in exponential form, so I'm going to do 2 to the power, 2 to the x equals 1 over 8. Now, this one is kind of a different one to solve because x is in the power. It didn't come out like this where it was equal to x. So let's go back and look at it a little bit more closely. I didn't pay attention when I was doing it. But you see how it says equals x at the beginning? Since it already says equals x, I don't need to do this. I just need to put that in Desmos because that's what x is, and x is what I'm looking for. So I should have paid more attention there, but I didn't. So all I'm going to do here is functions, miscellaneous, log, base 2 of 1/8, and you get -3. And so I don't want to write it in exponential form because that's not going to help me solve it. Okay. All right, let's look at number 13. What's the understood base here? Whenever there's a natural log, it's understood that there's an e down here. Okay? And so what we want to do is we want to rewrite it. We're going to write e to that power equals x minus 1. All right, we're trying to get x by itself, so we want to add 1 on both sides. So we would just put e squared plus 1, and that will give us the answer of 8.38 or 39. So that's when you start with a log. Alright, the last three questions, notice how they already say log 3, and then it tells you what they're taking the base of. To solve these equations, as long as log and base is the same on both sides, basically you can just get rid of the logs because I know that the things will be the same. So I'll just have x minus 5 equals 2x minus 8. And then you just solve it. So I want to get the x's together. Maybe I want to subtract x on both sides. It's still trying to get x, so maybe I want to add 8 on both sides. And so x is 3. Again, you can do that in Desmos if you prefer. I'll show you just real quick just to make sure that we understand all the different ways. So log base 3 of x minus 5. Let's see, I should have put parentheses in there. X minus 5. And then I want to move that other one over, so minus, and then I have to do the other log. And I'm looking for where it crosses the x-axis. It's hard to tell here, so maybe I'll go back home and see if home will help. So actually I made up a bad problem here, because if you go to Desmos, there's not an answer, and no matter how much I zoom in and out, it doesn't cross the x-axis. The reason is because whenever x equals 3, if you go back and plug 3 in, it would be log of a negative number, and I told you you can't ever take log of a negative number. This would be a case where that does not work, and so our answer would actually be no solution. So interesting that I put that problem on there. That wasn't what I was expecting, but still a good thing for you to see. So we still have to figure out which equation to use. There's the 3 equations that we've been using. We still are going to use those equations. So number 17 says we have a town with a population of 5,000 that grows 3% per year. How long before it doubles? Again, I don't see the word compounding, so I know I'm going to use that basic equation that we use most of the time. Alright, 5,000 is my initial amount. It's the amount to start with. Rate is 3%, so 0.03. The question is to figure out how long. That means t is what I'm looking for, so I'm just going to put a t up there because I don't know how long it will be. And it says how long for it to double. Well, if I start with 5,000, double 5,000 would be 10,000. So 10,000 is what I'm looking for there. I'm wanting to know when this equation would equal 10,000. Okay. Now, I want to show you both ways to solve it, but I want to show you very quickly. I think it's easiest just to put it in Desmos. So, if I were going to do this one, I would put 10,000 minus 5,000, 1 plus 0.03 raised to the t. Oh, x. Anytime we got a t, we put an x. And then our answer comes out right there. It's 23.45. So this one's nice because it gave us the equation. It could have told us compounded continuously, but it's the same. It wants to know how many days until there's only 5 grams remaining. So basically all I'm going to do is just make that equal to 5. 15 is the amount that it starts with. And then I'm just going to put it into Desmos. So I will get the answer from there. 5 minus 15 e to the negative 0.087 t or x. And I'm looking for where it crosses the x-axis.